Welcome to section 8.4, multiplying special cases. Today's objectives are to find the square of a binomial and to find the product of a sum and a difference. So here we go, multiply each pair of binomials and see what patterns you see in the products. If we multiply these together, the top one, we get x times x, which is x squared. Then we get x times negative 2 is negative 2x. Negative 2 times x is negative 2x. And then we have negative 2 times negative 2, which is 4. And when you simplify this, you get x squared minus 4x plus 4. Then we have 3x squared. The next one we have 3x plus 2 times 3x plus 2. We get 3x times 3x, which is 9x squared. Then we have 3x times 2, which is 6x. Then we have 2 times 3x, which is, again, 6x. And then 2 times 2, which is 4. And when we simplify this, we get 9x squared plus 12x plus 4. We do another one. We have 4x minus 1 squared. And when you look at this, you might start seeing a pattern. When we do this, the first term times the first term is just the first term squared. And we get 16x squared. You might notice on the first two, we have a negative 2x and a negative 2x when we multiply, because we have the same numbers multiplied together twice. So in this case, we'd have 4x times a negative 1, and we'd do it twice. So 4x times a negative 1 is negative 4x. If we do that twice, we have negative 4x and negative 4x, which is negative 8x. Then we have the last term multiplied by itself. On the top two, you had negative 2 times negative 2, which was 4. You had 2 times 2, which is 4. Do the same thing. Negative 1 times negative 1, which is 1. For this last one, we're going to do the same thing. The first term multiplies by itself, 5x, and we square it. 5x times 5x is 25x squared. And then we're going to do that 5x times 3, but we're going to have to do it twice. We'll have a 5x times 3 and a 3 times 5x. So 5x times 3 is 15x. We do that twice, we get 30x. And then we multiply the last number by itself, because when we expand it out, you would multiply it by itself. 3 times 3 is 9. So we have some patterns here. The first pattern we have is that the first term is just multiplied by itself. So you take the first term and square it. Then when you multiply those other two terms together, you do it twice. So basically what you end up doing is multiplying the two terms together, the 5x and the 3 for the last one, and doubling it, because you get that term twice. You get 15x twice. Or like you see up on number 2, you have 6x twice. First term, you have negative 2x twice. So we multiply them together, the 5x and the 3 for the last one, and double it. You'll notice we always multiply the last term by itself. So we get the positive answer at the end. And in this case, it's a positive 9 for our last one. So the patterns you get are the first term is squared. The middle term happens because you multiply the first and last terms of your binomial twice. So you multiply the first and last terms and double it. And the last term, is the last term squared. And it's always positive. Those are the patterns hopefully you'll see. We can use this. It's a nice shortcut when we have binomials squared. Now we have a sum and a difference. You'll notice we have the same terms in each binomial, but one has a plus and one has a minus. So let's see what happens with these. If we have x times x, so we get x squared. We have x times negative 7, we get negative 7x. We have 7 times x, we get a positive 7x. And then 7 times negative 7 is negative 49. This simplifies to x squared minus 49. Do the same thing for the next one. 2x times 2x. We get 4x squared. 2x times negative 1, negative 2x. 1 times the 2x, positive 2x. 1 times negative 1, minus 1. When we simplify, we have 4x squared The negative 2x and the 2x cancel out to 0, and we get 4x squared minus 1. For the third one, 5x times 5x, we get 25x squared. 5x times 7, 35x. Negative 7 times 5x is negative 35x. And 7 times negative 7 is negative 49. Combine our common terms, or like terms, we get 25x squared. 35x minus 35x is 0, and we get minus 49. And our last one, we have x minus 3 times x plus 3. We get x squared, x times x. X times 3 is 3x. Negative 3 times x is negative 3x. And we take negative 3 times 3 and get negative 9. So we have x squared minus 9. You should hopefully notice something with these patterns. I'm circling all our final answers so you can see what happens. You will notice that none of them have a middle term. That is a big key right there. No middle term. So what we do when we have these, we also have the first term is squared because we're always multiplying the first term by itself. We have the first term is this term squared. We always have a minus sign in between. You'll notice every single one of these has a minus. And our last term of each of these is just squared. It's always the first term squared minus the last term squared. That is the pattern we see when we do these products. And we can use these again for nice shortcuts. So if we have the square of a binomial, it is always this. We take the first term, in this case a is squared. Then we have a times b, but we end up doing it twice, so we get 2ab. And then we always have the last term multiplied by itself, and we get a b squared. So if you have an a plus b, a binomial squared of that form, it's always going to be a squared plus 2ab plus b squared. The first term squared plus 2 times the a and the b multiplied together plus b squared. If we have a minus sign in between, we get the first term squared. This time we're going to have a minus 2ab because a times negative b is negative ab. We have 2 of them. And we have a b squared. Negative b times negative b, when you square it, is going to be a positive b squared. So hopefully you'll notice here, when you have a binomial squared with a plus sign, your middle term is a plus sign. If you have a negative, the middle term is a negative. Those match. The first and last terms are always positive when you square a binomial. The first and last terms are always positive. The middle term matches the binomial's sign. All right, we have the product of a sum and difference. We take and get a squared minus b squared because the middle term is going to cancel itself out. So this is our shortcuts. If you know the shortcuts, it will save you a ton of time. It will also help you immensely when we factor later on this chapter. If you can use these rules, multiplying of special cases, this will pay dividends when we have to factor special cases later on in the chapter. So please use these, memorize these. They will save you time now, and they will save you a lot of time later. If we have 4x minus 5 all squared, we have a binomial squared. We are just going to take the first term and square it. 4x squared, 4x times 4x is 16x squared. We're going to multiply the two terms together. 4x times negative 5 is negative 20x. And we are going to double it. So we have negative 20x doubled is negative 40x. We take the last term and square it. Negative 5 squared, negative 5 times negative 5 is a positive 25. We have c plus 7 squared. We square the first term, c times c. We multiply c times 7, we get 7c doubled. 7c times 2 is 14c. And then 7 times 7, or 7 squared, is 49. And last one, we have 3w minus 2 all squared. That's our binomial squared. We square the first term, 3w squared. 3w times 3w is 9w squared. Multiply the two terms together and double it. 3w times negative 2 is negative 6w. Negative 6w twice is negative 12w. And then negative 2 times itself is a positive 4. One thing, again, I hope you notice, is that when we have a minus sign here, our middle term is minus. We have a positive here, our middle term is positive. Those do match. So square the first term, multiply the two terms together and double it, square the last term. That's your shortcut for binomials squared. Then we have our sum and differences. This is even easier. If you remember, we have the same terms with just different signs between them. This works for binomials. We square c times c is c squared. And then negative 10 times 10 is negative 100. And we're done. This only works if the first and last terms of the binomial have the same numbers, same variables, with a different sign between. If it doesn't have the same numbers, then you have to go through what we did before with FOIL. But if we have a sum and a difference, or in this case a difference and a sum, then we can just square the first term and multiply the negative 10 times 10. Or you can look at it as the first term squared minus the last term squared. So we have 4t plus 3 and 4t minus 3. We have a sum and a difference. So 4t squared is 16t squared minus the last term squared. 3 squared is 9. For number 3, we have 5y plus 6 times 5y minus 6. We square the first term, so 5y squared is 25y squared. We subtract, we always have a minus sign, and 6 squared is 36. And lastly, we have 3x minus 3 and 3x plus 3. 3x squared is 9x squared. Minus the last term squared, 3 squared is 9. So if we remember these, it will make this part, multiplying binomials together, easier if you remember these special rules for binomial squared or a sum and a difference. And they will really help you when we factor later on, if you can recognize these. All right, last thing we have is an area problem. A square brown tarp has a square green patch in the corner. The side length of the tarp is x plus 8, and the side length of the patch is x minus 1. What is the area of the brown part of the tarp? So here we have our overall square is x plus 8 by x plus 8. And our small square in the middle is x minus 1. To solve this, we take the area of the large minus the area of the small. So the area of the large is x plus 8 times x plus 8, which is x plus 8 squared. And we subtract off the area of the small, which is x minus 1 squared. Then we're going to use our special rules. We have a binomial squared. We square the first term. Multiply 8 times x together, we get 8x, and double it for 16x. And then 8 times 8 is 64. Then we're going to subtract off the second binomial squared. And you do need to use a parentheses here, because we're subtracting off the whole binomial squared. We have x times x, which is x squared. We have negative 1 times x, which is negative 1x. Doubled is negative 2x. And negative 1 squared is a positive 1. So now I'm going to rewrite this and distribute my negative sign into my parentheses. We have x squared plus 16x plus 64 minus x squared plus a 2x, because we're bringing this in, minus 1. Now we combine like terms. We have an x squared and a minus x squared. They cancel out. We have a 16x and a 2x, which is 18x. And then we have 64 minus 1, which is 63. And this is the area of the brown tarp. All right, remember when we do these area problems, the area of the larger, subtract out the area of the smaller. to find the area left. That is all for section 8.4. This was multiplying special cases. Please use the rules that we learned today when you do your homework. The more you understand how to multiply special cases, the easier it will be later on in the chapter when we have to factor special cases. Thank you for watching, and have a nice day.